Session 5. Variables. Introduction. Variables are the gears and cogs that make experiments run. Effective selection and manipulation of variables make the difference between a good experiment and a poor one. This study session will expose you to 3 kinds of variables that must be carefully considered before starting an experiment: independent, dependent, and control variables. Learning outcomes. When you have studied this session, you should be able to 1. Select an independent variable for experimentation. 2. Select a dependent variable for experimentation. 3. Control variables. And 4. Discuss the relevance of using multiple independent variables in an experiment. Independent variables. In true experiments, independent variables are those manipulated by the experimenter. The brightness of a light, the loudness of a tone, the temperature of a room, the number of food pellets given to a rat, all are independent variables, since the experimenter determines their quality and quantity. Independent variables are selected because an experimenter believes they will cause changes in behavior. Increasing the intensity of a tone should increase the speed with which people respond to the tone. Increasing the number of pellets given to a rat for pressing a bar should increase the number of times the bar is pressed. When change in the level, in brackets amount, of an independent variable causes a change in behavior, we say that the behavior is under control of the independent variable. Failure of an independent variable to control behavior, often called null results, can have more than one interpretation. First, the experimenter may have guessed incorrectly that the independent variable was important. The null results may be correct. Most scientists will accept this interpretation only reluctantly, and so the following alternate explanations of null results are common. The experimenter may not have created a valid manipulation of the independent variable. Let us say you are conducting an experiment on children in primary 2, and your independent variable is the number of small pieces of puff-puff they get after each correct response. Some children get only 1, whereas others get 2. You find no difference in behavior. However, if your independent variable had involved a greater range, that is, from 1 piece of puff-puff to 10 pieces of puff-puff, perhaps you would have obtained a difference. Your manipulation might not have been sufficient to reveal an effect of the independent variable, or perhaps unknown to you. The class had a birthday party just before the experiment started, and their little tummies were filled with ice cream and cake. In this case, maybe even 10 pieces of puff-puff would not show any effect. This is why, in studies of animal learning with food as a reward, the animals are deprived of food before the experiment starts. We can see that the experimenters must be careful to produce a strong manipulation of the independent variable. Failure to do so is a common cause of null results, because there is no way to determine if the manipulation has failed or the null results are correct. Experimenters cannot reach any conclusions regarding the effect of the independent variable on the dependent variable. Other common causes of null results are related to dependent and control variables, to which we now turn. Dependent variables. The dependent variable is the response measure of an experiment that is dependent on the participants' responses to our manipulation of the environment. In other words, the participant's behavior is observed and recorded by the experimenter and is dependent on the independent variable. Time elapsed before a participant sits down at a table defended by a research assistant. The speed of a worm crawling through a maze. The number of times a rat presses a bar. All are dependent variables because they are dependent on the way in which the experimenter manipulates the environment. In the library example, we might predict that a participant will be more reluctant to sit down at a table that is defended by an assistant who displays a forbidding expression than if the assistant assumes a congenial expression. In this instance, the participant's behavior is dependent on the expression that we instruct the assistant to adopt. The time that elapses until the participant sits down at the table is the dependent variable of interest. Criteria for selecting dependent variable. One criterion for a good dependent variable is stability. When an experiment is repeated exactly, same participant, same level of independent variable, and so on, the dependent variable should yield the same score as it did previously. Instability can occur because of some deficit in the way we measure some dependent variable. Assuming that we wish to measure in grams the weight of an object, say a candle, before and after it is lit for 15 minutes, we use a scale that works by having a spring move a pointer. This spring contracts when it is cold and expands when it is hot. As long as our weight measurements are taken at constant temperatures, they will be reliable. But if temperature varies while objects are being weighed, the same object will yield different readings. This is because our dependent variable lacks stability. Null results can also be caused by inadequacies in the dependent variable, even if it is stable. The most common cause is a restricted or limited range of the dependent variable, so that it gets stuck at the top or bottom of its scale. Imagine that you are teaching a rather uncoordinated friend how to bowl for the first time. Since you know from introductory psychology that reward improves performance, you offer to buy your friend a drink every time he or she gets a strike. However, your friend got all gutter balls, so you took all the drinks yourself. Thus, you can no longer offer a reward. Therefore, you expect a decrement in performance. But since it is impossible to do any worse than all gutter balls, you cannot observe any decrement. Your friend is already at the bottom of the scale. This is called a floor effect. The opposite problem, getting 100% correct, is called a ceiling effect. Ceiling and floor effects prevent the influence of an independent variable from being accurately reflected in a dependent variable. Control variables. A control variable is a potential independent variable that is held constant during an experiment because it is controlled by the experimenter. For any one experiment, the list of relevant control variables is quite large, far larger than can ever be accomplished in practice. In even a relatively simple experiment, for example, requiring people to memorize 3-letter syllables, there are many control variables involved. Time of the day changes your efficiency. Ideally, this should be controlled. Temperature could be important because it might also affect memory performance. Intelligence is also related. the list could be extended. In practice, an experimenter tries to control as many salient variables as possible, hoping that the effect of uncontrolled factors will be small relative to the effect of the independent variable. Although it is always important to exercise strict control over extraneous factors, it is even more critical when the independent variable produces a small effect on the dependent variable. Holding a variable constant is not the only way to remove extraneous variation. Statistical techniques also control extraneous variables. Holding a variable constant is the most direct experimental technique for controlling extraneous factors, so we limit our definition of control variables to only this technique. Null results often occur in an experiment because there is insufficient control of these other factors. That is, they have been left to vary systematically with the independent variable. Depending on the relationship between an extraneous variable and an independent variable, these uncontrolled variations can either obscure or inflate the effects of the independent variable on the dependent variable of interest. The problem of extraneous variations occurs more often in studies that are conducted outside of laboratories, where the ability to hold control variables constant is greatly limited. Activity. Name the variables. Understanding independent, dependent, and control variables is so important. We have included some examples for your use in checking your understanding. For each situation, name the 3 kinds of variables. The answers follow at the feedback section in this page. 1. An automobile manufacturer wants to know how bright brake lights should be to minimize the time required for the driver of a following car to realize that the car in front is stopping. An experiment is conducted to answer these. Name the variables involved. 2. A pigeon is trained to peck a key if a green light is illuminated, but not if a red light is on. Correct pecks are regarded by giving it access to green. Name the variables involved. 3. A social psychologist does an experiment to discover the conditions of men crowded in a telephone booth. Name the variables involved. 4. A therapist tries to improve a patient's image of himself. Every time the patient says something positive about himself, the therapist rewards this by nodding, smiling, and being extra attentive. Name the variables involved. Feedback section. 1. Independent variables in bracket manipulated, such as intensity, brightness of brake lights. Dependent in bracket observed variable, such as time from the outset of the brake lights until the depression of brake pedal by following driver. Control in bracket constant variables, such as color of brake lights, shape of brake pedal, external illumination, etc. 2. Independent variables, such as color of lights in bracket red or green. Dependent variable, number of key pecks. Control variables, hours of food deprivation, size of key, intensity of red and green lights, etc. 3. Independent variables, gender of participants. Dependent variable, rating of discomfort. Control variables, size of telephone booth, number of persons in bracket 6 crowded into booth. size of individuals, etc. Independent variables. Actually, this is not an experiment because there is only one level of the independent variable. To make this an experiment, we need another level, say rewarding positive statements about the patient's mother-in-law and ignoring negative ones. Then the independent variable will be kind of statement rewarded. 4. Dependent variable. Number or frequency of statements. 4. Independent variables. Actually, this is not an experiment because there is only one level of the independent variable. To make this an experiment, we need another level, say rewarding positive statements about the patient's mother-in-law and ignoring negative ones. The independent variable will be kind of statement rewarded. Dependent variable. Number or frequency of statements. Control variables. Office setting, therapist, etc. Multiplicity of variables in an experiment. This session discusses the importance of using multiple independent variables in an experiment. The possibility of using multiple dependent variables in an experiment is also discussed. Examples are given for illustration. Multiple independent variables. It is unusual to find an experiment reported in a psychological journal in which only one independent (manipulated) variable is used. The typical experiment manipulates from 2 to 4 independent variables simultaneously. This procedure has several advantages. First, it is often more efficient to conduct one experiment with, say, 3 independent variables than to conduct 3 separate experiments. Secondly, experimental control is often done better, since with a single experiment, some control variable, time of the day, temperature, humidity, and so on, are more likely to be held constant than with 3 separate experiments. Thirdly, and most importantly, the result generalized, that is, shown to be valid in several situations across several independent variables, are more valuable than data that are yet to be generalized. Just as it is important to establish generality of results across different types of experimental subjects, experiments also need to discover if some results is valid across levels of independent variables. Fourthly, this allows us to study interactions, the relationships among independent variables. We illustrate these advantages with some examples. Let us say we wish to find out which of 2 kinds of reward facilities the learning of geometry by high school students. The first reward is an outright cash payment for problems correctly solved. The second reward is early dismissal from class, that is, each correct solution entitles the student to leave class 5 minutes early. Assume that the results of these hypothetical experiments show early dismissal to be the better reward. Before we make early dismissal a universal rule in high school, we should first establish its generality by comparing the 2 kinds of reward in other classes, such as history or biology. Here, subject matter of the class would be a second independent variable. It would be better to put these 2 variables into a single experiment than to conduct 2 successive experiments. This would avoid problems of control, such as one class being tested the week of the big football game, where no reward would improve learning, and the other class being tested the week after the game is won, in bracket, when students felt better about learning. When the effects produced by one independent variable are different at each level of a second independent variable, we have an interaction. The search for interaction is a major reason for using multiple independent variables per experiment. This can better be demonstrated by example. Martel and Willis 1993 were interested in discovering how feedback about a group's performance would influence what subjects remembered about the group's behavior. Prior to observing the same work group, subjects were given either positive or negative feedback concerning the group's performance. Subjects who received positive feedback were told that a panel of experts had ranked the group among the top 20% of all work groups. Subjects in the negative feedback condition were told that the group ranked in the bottom 20%. There were two independent variables. The subjects were first given either the positive or negative feedback. All subjects watched the same videotape of a work group. Work group members displayed both effective and ineffective behaviors in their attempt to build a bridge of blanks and ropes across a pool of water. So, all subjects observed the same videotape in which the group engaged in both effective and ineffective behaviors. Thus, the two independent variables were performance feedback, in brackets, positive or negative, and type of behavior observed, in bracket, effective. After subjects watched the videotapes, they were shown a list of behaviors and then asked to decide which ones they had actually observed. The dependent variable then was the proportion of effective and ineffective behaviors that subjects attributed to the work group. When subjects observed effective behaviors, a lower proportion of behaviors attributed to the group were checked than when they observed ineffective behaviors. When subjects were given a positive feedback, a higher proportion of behaviors attributed to the group were found. However, these simple interpretations of the results can be misleading. Effective behavior does not always produce a lower proportion of behaviors attributed to the group as might be concluded. Instead, the direction of the effect of behavior depends on the kind of feedback given. Only for negative feedback does effective behavior produce a lower proportion of behaviors attributed to the group. For positive feedback, this is not true. Remember an interaction between two variables indicates that the effects produced by one independent variable, in bracket, performance feedback, are not the same at each level of the second independent variable, in bracket, effective versus ineffective work behavior. This is exactly what was found. Subjects who received a positive feedback regarding the work group recognized a greater proportion of effective than ineffective behaviors. In contrast, subjects who received a negative feedback responded in the opposite manner, recognizing a greater proportion of ineffective as opposed to effective behaviors in the work group. This judgment represents an illusion of memory created by exposure to positive or negative feedback. Despite the fact that the subjects in the two conditions actually saw the same videotape, their memories for the group behaviors were biased by their prior expectations. The effects produced by the manipulation of performance feedback depend on whether the behaviors are ineffective or effective, with subjects recognizing a greater proportion of behaviors that are consistent with their feedback condition, in brackets. For example, a greater proportion of effective behaviors when giving a positive feedback. If performance feedback produce similar results for both effective and ineffective behaviors, then both feedback groups would recognize either more effective behaviors or more ineffective behaviors of the work group. Now let us imagine that this experiment was performed with two feedback conditions, but that the experimenters decided to ignore or fail to consider the distinction between effective and ineffective work behaviors. In other words, the experimenters investigated the effect of performance feedback on work group behavior in general. The experimenters would have been forced to conclude that the performance feedback produces little or no effect on the proportion of behaviors attributed to the work group. You can see that by designing the experiment this way, the experimenters would have ended up with null results, and as a consequence, missed discovering an important finding regarding the effects of performance feedback on work behavior ratings. Thus, there are dangers in overlooking important variables when designing experiments. From the results in this example, the actual result shows an interaction. The effects of one independent variable depend on the level of the other independent variable. Subjects were more likely to endorse or remember work behaviors that were consistent with the feedback that were given about the work group. Many experiments include two or more independent variables so that the results may contain an interaction. Because of the frequency with which you are likely to encounter interactions, we present another example of two variable experiment to help you practice interpreting the results of complex experiments. In the experiment on social loafing by Brickner, Harkins, and Ostrom, 1986, the authors wanted to determine the effect of personal involvement in a task on the amount of social loafing shown on that task. Brickner and her associates noted that low involvement tasks such as clapping and generating uses for a knife had been used in earlier research on social loafing. The authors reasoned that the effort devoted to a task should be related to the intrinsic importance or personal significance that the task has for the individual. High personal involvement in a task should reduce social loafing because individuals should put forth a substantial amount of effort on such tasks, regardless of whether their individual performance is monitored. So, the researchers varied the subject's involvement in the task and also varied the amount that the individual effort could be assessed. If their reasoning was correct, there should be an interaction. Low involvement should lead to social loafing, reduced effort when the individual's effort cannot be assessed. But high involvement should lead to about the same amount of effort, whether or not individual effort could be identified. Brickner and his associates had college students generate as many thoughts as they could in a 12-minute period about a proposal to implement senior comprehensive exams, which a student would have to pass in order to graduate. In the high involvement condition, the students were led to believe that the proposal will be instituted at their college prior to their graduation. Thus, the addition of comprehensive exams as one prerequisite to graduation should have high personal relevance. In the low personal involvement condition, the students were led to believe that the exams would be instituted later at another college. The possible identifiability of individual effort was also manipulated by instructions. Subjects wrote each of their thoughts about comprehensiveness on an individual slip of paper. In the low identifiability condition, the subjects were told that their thoughts would be collected with those of other subjects because the committee evaluating the thoughts wanted to assess the range of opinions for the group as a whole. In the high identifiability condition, the subjects were told that their opinion would be considered separately from those of others because the committee in charge wanted to assess individual responses. To summarize, the dependent variable was the number of thoughts generated in the four conditions: low identifiability and low involvement, low identifiability and high involvement, high identifiability and low involvement, high identifiability and high involvement. A number of thoughts were generated against identifiability for the two involvement conditions. The results show that earlier social loafing research is replicated in the low involvement condition. Fewer thoughts were generated when the subject believed that their individual performance was not being assessed. When there was high involvement, the variables interacted and the effects of identifiability depended on the level of task involvement. In other words, social loafing and therefore diffusion of responsibility is less likely to occur when a person is confronted with a personally involving task than when the task does not have much intrinsic interest. Multiple dependent variables. The dependent (observed) variable is used as an index of behavior. It indicates how well or poorly the subject is performing. It permits the experimenter to score behavior. The experimenter must decide which aspects of behavior are relevant to the experiment at hand. Although some variables traditionally have been used, this does not mean that they are the only or even the best indices of behavior. Take, for example, the behavior of a rat pressing a bar or a pigeon pecking a key, responses that are used in studies of animal learning. The most common dependent variable is the number of presses or pecks observed. But the force with which a key is pecked can also lead to interesting findings, as can the latency (the time taken to respond). Researchers can usually come up with several dependent variables that may be appropriate. Let us say we wish to study the legibility of the typeface that you are now reading. We cannot observe. Here are some dependent variables that had been used in the past. Retention of meaningful information after reading text. Time needed to read a fixed number of words. Number of errors in recognizing single letters. Speed in transcribing or retyping text. Heart rate during reading. And muscular tension during reading. And this list is far from exhaustive. Reasons of economy argue for obtaining as many dependent measures at the same time as is feasible. Despite this, the typical experiment uses only one or, at the most, two dependent variables simultaneously. This is unfortunate. Just as the generality of an experiment is expanded by having more than one independent variable, it is also expanded with several dependent variables. The reason why more dependent variables are not used at once is probably because it is statistically difficult to analyze several dependent variables at once. Although modern computer techniques make the calculations quite feasible, many experimental psychologists have not been well trained in these multivariate statistical procedures and thus hesitate to use them. Separate analysis could be conducted for each dependent variable by itself, but this loses information in much the same way that a separate analysis of independent variables ignores interactions. Multivariate analysis is complex. Nevertheless, you should be aware that it is often advantageous to use more than one dependent variable in an experiment. Study session summary. In this study session, we discussed that independent variables are selected because an experimenter believes they will cause changes in behavior. Null results are obtained when an independent variable fails to cause changes in behavior. Null results can have more than one interpretation. This implies that experimenters must be careful to produce a strong manipulation of the independent variable. Independent variable is manipulated by the experimenter, whereas the dependent variable is observed and recorded. Ceiling and floor effects result from an inadequate range for the dependent variable. They prevent the influence of an independent variable from being accurately reflected in a dependent variable. The dependent variable is the response measure of an experiment that is dependent on the participants' responses to our manipulation of the environment. A control variable is a potential independent variable that is held constant during an experiment. It is not manipulated during an experiment. We also noted that the levels of one independent variable are differentially affected by the levels of other independent variables. End of study session 5. Thank you for listening.